Let's take a look at example 1. Here they've given us f of x equals 1/3 x cubed minus x, and they want us to determine the open intervals on which the graph is concave, up or down. Okay, so let's begin by taking the first derivative. So we have f of x is equal to 1/3 x cubed minus x, and prime of x is going to be 3 times 1/3 is 1, x squared, power times base down 1, minus derivative of x is 1. And to find the critical values for f prime, we want to set this equal to 0 and solve. And we get x equals -1, comma, x equals 1. And so we have critical values for f prime of x. Now let's take the second derivative. So f prime of x is equal to, and the derivative of x squared minus 1 is just 2x. And set that equal to 0 to find critical values for f double prime. And so we have x equals 0. And so this would be these are our critical, this is the critical number or critical value for f double prime of x. All right, so first I want to make a sign chart for f prime of x. And so for this sign chart, notice that my critical values are laid out here, -1, +1, and I've labeled this for f prime of x. And so I just want to think about, okay, what are the values of f prime of x for a value less than -1, say -2. So this would be our test value, and 0 between -1 and 1, and let's say 2 to the right of 1. So plugging in, we have a positive value for the first derivative. We have a negative value when it is between -1 and 1, and we have a positive value when it is to the right of 1. And so what that means for our original function is that it is increasing on this interval, decreasing on that interval, and increasing on this interval. Now, if I'm going from increasing to decreasing, that means that this point of, or this critical value must be a maximum. And that since I'm going from decreasing to increasing, this critical value must be a minimum. Now onto a sign chart for our second derivative test. So my critical value here was 0, so let's go ahead and lay that out. And if we plug in -1 into our second derivative in place of x, we get -2, so that's a negative value. And if we plug in 1 to the right of 0 as a test value, 1 times 2 is 2, that's positive. So we get a positive second derivative. What does that mean? Well, concavity. So negative means concave down, and positive means concave up. And that means, since the concavity just changed, that my critical value 0 is a point of inflection. All right, let's summarize our conclusions. So f of x increases on the interval from -∞ to -1, union 1 to infinity. F of x decreases on the interval from -1 to 1. The original function is concave down on the interval from -∞ to 0. And it is concave up on the interval from 0 to infinity.